All right, so where we're at right now is sort of in the separable equations part. And so just to review, okay, where we're at, okay. So a differential equation of first order can be written in this form, right? So dy dx is equal to an expression involving x and y. So the equation is separable if you're able to do this to that equation. So by multiplying or dividing, you're able to separate your y from your x. So your dx gets multiplied over here, and see if you can actually separate your x from your y by doing products or quotients, right? So if you're able to do that, then your equation is separable. And sort of we went through a few examples last time. Okay. So are there any questions before we move to the next few examples? All right. Okay. So example number 7. So dy dx is equal to an x plus y minus 4 squared. It's really bright. Okay. All right. So based on what we sort of define as separable, this is not separable. Even if you distribute, right, the square, this will not be separable because there's an x plus y. If it's an x plus y, there's no way you can divide the y and get it to the other side. So which means this is not separable. However, it is of the form like this. Dy dx is equal to a function involving a linear expression. So it involves an ax plus by plus c, a linear expression inside another function. So in this case, it's a I'm trying to figure out the term for it. The term for it, it's composition. There you go. So it's a composition of a linear expression in another function. So, but in this case, I have it in this form. Okay. So when this is what you have, a substitution can be made by letting u be equal to the linear expression. So let u be equal to ax plus by plus c. So on this problem, u is going to equal what? So what will be u equal on this problem? Okay. So it will u would be x plus y minus 4, right? So x plus y minus 4. All right, so that is your substitution, right? So u is equal to that linear expression. Now, much like any substitution you've done before, right? So like your u substitution in integration, you have to replace everything. So I have to replace dy dx um, on there as well. So the next step is after you make your substitution, you now have to take the derivative with respect to x. So the derivative of u with respect to x is du dx. Derivative of x with respect to x is going to be what? So derivative of x with respect to x is 1. Okay. Plus, and then y is dy dx, and then derivative of 4 with respect to x, 0. I don't have to put it there, but for later on, right? So for people reading the notes later, I just want to make sure they can see it. It's minus 0 on there. Okay. And then now I have to solve for dy dx. So based off of this, dy dx is equal to, so move this one over, you get du dx minus 1. So then now, completing my substitution. So I have, remember, dy dx is equal to x plus 4, sorry, x plus y minus 4 squared. So now making the substitution, this would be du dx minus 1, okay, is equal to u squared. And if I now solve for my derivative, this would be du dx is equal to u squared plus 1. Questions on that? Okay. Now this is going to be separable, right? So if you multiply dx on this side, you have to divide this whole expression to the side. And what you have is 1 over u squared plus 1 du is equal to dx. And then now integrating to both sides. And so if you integrate both sides, okay, you get what? So what's the left side then? So what's the integral of 1 over u squared plus 1? Your arctangent, right? So that would be your inverse tangent of u is equal to x plus c. And much like anything you've done before, when you do u substitution, after you do your integration, you put it back. So this is inverse tangent of x plus y minus 4 is equal to x plus c. Questions? All right, now you're not done because, again, notice there's only one y, and that means typically if there's only one y, I should be able to find my function explicitly. So first, get rid of the tangent. So you get x plus y minus 4 is equal to tangent of x plus c. Okay. And then move the 4 and the x, so y is equal to tangent of x plus c minus x plus 4. And there is your answer. Okay. Any questions on that? Any questions on it? Okay. So I want you to try one. Okay. So number 7 or number 8. Okay. So y prime is equal to cosine of y minus x. Right. So at the very least, try to get to your substitution and finish it, right? So at the very least, try to get to this part where you can separate it. And then we'll talk about how to integrate the resulting problem afterwards. I think the integration here is a little bit different. So we're gonna have to talk about how to do that. So at the very least, try to get to this part, right, where you separate the two variables. So right now, again, this is not separable, right? So there's no way to separate the y from the x because you have a y minus x, right? So the only way to separate them would be to add. And from what we talked about last time, you can only multiply and divide to separate the variables. So which means this is not separable. However, there is a linear expression inside another function on the other side of your differential equation, which means I can make the same substitution. This time, though, you have a different u. What is u on this problem? So what will be u? Mm, oh, there you go. Y minus x. Okay. So y minus x is inside the expression. So then now take the derivative with respect to x, right? So keep that in mind, right? You are doing derivative with respect to x. Okay. So go ahead and do that, right? So that means this would be du dx. This would be dy dx. And then derivative of x with respect to x is -1. Okay. All right. So go ahead and see if you can finish it. Okay. Let me post this. All right. So you do have to solve for dy dx. And when you do, right, dy dx is equal to du dx plus 1, right? So again, since your linear expression is going to change depending on the problem, then your dy dx is going to change as well, right? So keep that in mind, okay? So this one is now du dx plus 1, right? That's what we got over there, is equal to cosine u. And then subtract the 1, and so du dx is equal to cosine u minus 1 as an expression. Um, I'm gonna go ahead and divide this to this side. And so you're gonna have a 1 over cosine u minus 1 du is equal to dx. Okay. Now, as far as the technique goes that we're gonna do, to sort of explain it, the first thing I wanna do is get rid of the -1, right? So multiply -1 to both sides, and I'll explain why once we get through the technique that we're gonna use. So you're gonna have 1 over 1 minus cosine u du is equal to a -1 dx. Okay. But any questions first on how to get to this part? Okay, so now I'm out of space, so I'm gonna go ahead and flip this one over, right, and then copy the problem on the next page. Okay, so this is problem number 8. So I have a 1 over 1 minus cosine u du is equal to -1 dx. So we know how to do the left side. The left side, I'm sorry, the right side is easy. You get negative x plus c. How do I do the left side? Any ideas on how to integrate 1 over 1 minus cosine u? By the way, you cannot split the fraction, right? So you're unable to split that fraction on the left side, okay? You can only do it if the subtraction is on the numerator. If it's on the denominator, you can't do it. Any suggestions on the left side on how to do it? Any suggestions? Anything? Nothing? Okay. All right, so let's talk about the left side, right? So obviously I can't integrate it the way it looks right now. So there's nothing to do on this one. I cannot do a substitution on this one. There's no technique you can use. So integration by parts is gonna become messy on this one. So I don't want to do any of those just yet. So now, okay, let me copy the expression on this side. And so one of the problems here is that the cosine is at the bottom and there's really no identity to use because none of them are squared. So what you want to do is introduce a square. So the only way to do that on a fraction is to multiply by the conjugate. So by multiplying by the conjugate, the top is 1 plus cosine u. The bottom now becomes 1 minus cosine squared u. And what is 1 minus cosine squared u? So what will be the bottom if you simplify? So what is 1 minus cosine squared? Sine squared, right? So you get 1 plus cosine u over sine squared u. And now what it does is it moves the addition now to your numerator. And you can now split this up into individual fractions. And simplifying each one of these expressions, 1 over sine squared is cosecant squared. And this one, you have to split this up as a cosine over sine times a 1 over sine. So that would be a cotangent times a cosecant. So now the left side is a cosecant squared u plus a cotangent u cosecant u du is equal to a negative x plus c. And you still have to integrate this part. So what is the integral of cosecant squared? By the way, these two are one of your 20. Sorry, one of your 16. Negative cotangent and cotangent cosecant. You might remember it as cosecant times cotangent, which is the same. It's negative cosecant is equal to negative x plus c. The negative is all over the place, so I'll go ahead and multiply everything by negative 1. So you get cotangent u plus cosecant u is equal to a positive x plus c1, right? So it's now a different constant on there because I multiplied by negative 1. And then replace u with y minus x. So you get cotangent y minus x plus cosecant y minus x is equal to x plus c1. And since there are multiple y's on here, there's really no way to solve for y explicitly. And so you leave your answer in this form, and that is your final answer. Questions on that? Any questions on it? I'm trying to find something here and I can't find it. There you go. Anything other questions? Okay. All right, so that is one substitution, right? So one substitution is where the other side is sort of have an inner function involving a linear expression. So if you have something like that, then that substitution that we just did would work on that problem. Okay, and so now example number 9. So dy dx is equal to x minus y over x plus y. Okay. So again, it's not separable, right? So you can try multiplying this side, but there's an x plus and x minus. So which means the only way to move the y's would be to start adding and subtracting, and that's not going to work on a separable equation. Okay, so you won't be able to write it as a function of y times dy and a function of x times dx. So again, this is not separable. And looking at it, so there's a linear expression, but there's two kinds. So this cannot be done using the first type of substitution. So now I'm going to show you a different kind of substitution. So this can only be done if I have dy dx is equal to, on the other side, a function of y over x. So if I can write this side so that every variable is y over x, then I can complete the substitution. Okay. So on this one, I can do that by dividing everything by x. So if I divide everything by x, I have dy dx is equal to, so this times 1 over x is 1, minus y divided by x would be y over x, all over 1 plus y over x. So I multiplied 1 over x top and bottom, right? And so you're able to do that. And so in doing so, everything here involves a y over x. Okay. Questions? Questions on that? All right, so now obviously the substitution is let your letter be equal to y over x. So now to differentiate this from the other one, let's use a different letter. So we'll let v be y over x. All right, then now the same thing as before, I have to take the derivative, right? Now, if I take the derivative now, okay, if I leave it like this, I have to do the quotient rule on the right side, okay? I don't really like doing quotient rule because they give me fractions. So I need to multiply both sides by x. So that means y is v times x. And then do implicit on this one, which we've been doing anyway already. So when I do, I get dy dx is equal to, and this is a product rule, so derivative of v, which is dv dx times x, plus v, and derivative of x is 1. Questions? Any questions on it? Okay. Now note, unlike your linear substitution, that one, it's going to change depending on your linear expression. This one is not. It's always y over x, which means dy dx is fixed, right? So here, dy dx is equal to x dv dx plus v. And so these are essentially fixed on this kind of substitution, right? So this part is fixed and this part is fixed, okay? Because our substitution is always this, right? So since it's always that, this is always our dy dx, okay? Questions? Okay. So let's try this out, okay? So now let's make the substitution. So this one is actually a little bit easier because everything you just substitute. So dy dx is this expression. So you have x dv dx plus v. What happened? Oh, is equal to um, 1 minus v over 1 plus v. Okay. And the same thing as before, I try to solve for the derivative, right? And so move the v over. So you're going to have x dv dx is equal to 1 minus v over 1 plus v. And then if I move this over, I get a minus v. Now, before I sort of get into x, it's probably a good idea to write this as one fraction. So I do that by multiplying top and bottom by the LCD, which is 1 plus v. Okay. And in doing so, I now have a 1 minus v minus, so distribute this out, you get v, and then this times this is a minus v squared, everything over 1 plus v. Which simplifies to x dv dx is equal to 1 minus 2v minus v squared all over 1 plus v. Questions? Any questions on that? Okay. All right, now this is separable, right? So everything here is v. I can just divide the whole thing on that side and then divide the x on this side as well. Obviously, this one will flip because you're dividing. And this is what you end up getting. A 1 plus v over a 1 minus 2v minus v squared dv is equal to 1 over x dx. Questions? All right, now it's easy to do the right side, right? So again, the right side is pretty simple to do, okay? How do I do the left side? So how do I integrate this side of the problem? Any ideas? I don't think it's factorable. It's not factorable. Because if you factor out a negative 1, that would be v squared plus 2v minus 1, and that doesn't factor. Anything else? So it's not factorable. Anything else on the left side? It's easier than you might think. U substitution. It is a U substitution, right? So if you let U be your denominator, what is du? So is use this one. What is du? Negative 2 minus 2v dv. And if you factor out a negative 2, it's a negative 2, 1 plus v. And I have that. 1 plus v is right there. So it's just missing a negative 2. So you put a negative 2 here, right, on the problem. And then you put a negative 1/2 in the front, right? So that's going to leave you with a 1/2, negative 1/2 factor in the front. So let me write this out a little bit nicer so I have space to write out the 1/2. And so the left side is a natural log as well, because you're going to get 1 over u, the same thing on this side. So what you have is a negative 1/2 ln of u, sorry, ln of v, sorry, not v, sorry, ln of 1 minus 2v minus v squared, and then you have ln x on the other side. And then if you want to clean this up, so multiply both sides by negative 2. So this becomes negative 2 ln absolute value of x plus c1. And this would be ln 1 minus 2y over x minus y squared over x squared. Now there's no way to solve for a y, but I should be able to eliminate the natural log. And so again, this is something we have seen already from before. So let me finish it right above because I need to use new paper anyway. So if I do the exponential, I'm going to have 1 minus 2y over x minus y squared over x squared inside the absolute value equals e to the negative 2 ln of absolute value of x plus c1. And we've seen this one already before, right? The c1 becomes a constant. At the same time, the absolute value can be absorbed by that constant. And you're left with 1 minus 2y over x minus y squared over x squared is equal to a c2. Then this negative 2 becomes the power, and you get 1 over x squared on there. And if you want to clean it up further, multiply everything by x squared. And so when you do, you get x squared minus 2xy minus y squared is equal to C2. And that is as simplified as you can get it as a problem on this problem. Any questions on this? Any questions on it? All right, let's try another one. Okay, so example number 10. Okay. So dy dx is equal to a 2xy over x squared plus y squared. So again, the fact that there's an x plus y, in this case, x squared plus y squared, there's no way to separate this using multiplication or division. So which means a substitution is going to be required on this problem, and there's no linear expression, okay? So my last hope is to change everything to a y over x, okay? So to do that, I need to divide something, right? Each term has to be divided by something. What do I divide into everything? Or what do I multiply to every term? Because 1 over x is not going to work this time. It's going to have to be x squared, right? So how do you know it's x squared? The way you do it is you look for the highest degree of your y. So the highest degree of your y is y squared. So that means for this to be y over x, the x also needs to be squared. So now that means the only option is to divide by x squared. Now, hopefully by doing so, it would work. So I'll give you some time to actually work this out and multiply 1 over x squared top and bottom, and then see what you get as an expression. All right, so when you do this, okay, the numerator, so one of the x would cancel. So you're left with y times 1 over x, which is 2 times y over x. Okay, over. Okay. Divide this by x squared. Well, that would be 1. Okay. And divide this by x squared, you get y squared over x squared. And if you factor out the square, you can do that because of the properties for your exponent. You're going to have y over x squared. So which means your substitution is going to work because everything here is y over x. Okay, so your substitution is v equals y over x, and then dy dx is always fixed. It's x dv dx plus v. And so now making the substitution, you get x dv dx plus v is equal to um, 2v over 1 plus v squared. And then move the v over. Okay. And then again, multiply by the LCD, which is 1 plus v squared, top and bottom. And so on the numerator, you're going to have 2v minus distribute the v, you get minus v cubed all over 1 plus v squared is equal to x dv dx. And combining like terms, you get x dv dx is equal to v minus v cubed all over 1 plus v squared. Oops, sorry. And then again, it is now separable in terms of x and v. So you get 1 plus v squared all over v minus v cubed dv is equal to, 1 over x dx. Questions? Any questions on that? Now, I'm not going to actually integrate this one, but tell me, how would I integrate the left side? So if we are going to do this on a problem, how do we integrate the left side? Any suggestions on the left side? So how would I do this one? Any suggestions? because I don't think a substitution would work because there's a 1, but the other one would be 3v squared and it's negative, and that's not what I have on the numerator. So I don't think that's going to work. So how do I do the left side? Suggestions? Anything? So this time though, your denominator factors. So if my denominator factors, okay, what can I do? So my denominator is going to factor out. If I factor this out, this would be v 1 minus v 1 plus v. So if the denominator factors, what method can you use to do the integration? Anyone? No one? And the reason why we're not doing it, because I know I'm not going to ask it on the test, okay, is partial fractions. Since the denominator factors, I can do partial fractions on this one. So this expression is equal to a over v plus b over 1 minus v plus c over 1 plus v. And so you can split the left side into individual linear expressions, would allow you to do natural log on each one. And so this is the method you have to use for this problem. Now, the reason I gave this problem was just to make sure you understand, oh, I have to divide by 1 over x squared on this one instead of 1 over x. But this integration is something I will not be asking on your tests. So any questions on this? Because we're done with 2.3, right? So this is 2.3, right? So 2.3 is done. Sorry, is it 2.3, 2.2? I think this is 2.2. Okay. So 2.2 is done. Okay. So that is separable equations. Okay. Any questions on this? Any questions? All right, so it's a perfect time to take a break right now. So let's go ahead and take a 10-minute break, okay? And then we'll do 2.3, which is another method of solving a first order differential equation, except it has to be linear. So it has to be a linear expression. So this is not linear because you have a y squared. So this is not going to work on the next section. So let's go ahead and take a 10-minute break, okay, and then we'll continue on 2.3 next.